Welcome everyone to Sham Discovers. Let's learn something new today. Before a single circuit was etched, the universe itself was computing. Every star, every galaxy, every atom follows incredibly complex algorithms. From the elegant dance of planetary orbits to the intricate folding of proteins, computation isn't just a human invention, it's a fundamental property of reality. We just learned to harness it. Our human journey into computation began not with electricity, but with beads and frames. The abacus, dating back thousands of years, was humanity's first true mechanical calculator. It allowed ancient civilizations to manage vast empires, track trade, and build monumental structures, proving that even the most complex calculations could be broken down into simple, repeatable steps. Fast forward to the 17th century. Visionaries like Blaise Pascal and Gottfried Leibniz pushed the boundaries, creating intricate mechanical calculators. Pascal's Pascaline used gears for addition and subtraction, while Leibniz's stepped reckoner could multiply and divide. These weren't just tools, they were philosophical statements, demonstrating that even reasoning could be mechanized. But the true father of the computer was Charles Babbage. In the 1830s, he designed the analytical engine, a machine so advanced it wouldn't be fully built for over a century. It had an arithmetic logic unit, conditional branching, and even memory. Babbage wasn't just building a calculator, he was envisioning a general-purpose programmable machine, the conceptual ancestor of every computer you've ever touched. Babbage's collaborator, Ada Lovelace, daughter of Lord Byron, saw beyond mere calculations. She realized the analytical engine could process symbols, not just numbers, and wrote what's considered the world's first computer program, an algorithm for the Bernoulli numbers. She grasped the profound potential of machine intelligence, centuries before its time, truly the prophetess of the digital age. Fast forward to the late 19th century. Herman Hollerith, inspired by railroad conductors' punch tickets, developed a system using punch cards to process the U.S. Census. This wasn't just faster, it was a revolution in data processing, laying the groundwork for IBM and the idea that information could be stored and manipulated electronically, not just mechanically. World War II accelerated computer development like nothing else. At Bletchley Park, Britain's secret code-breaking center, the Colossus was built. This massive machine, using thousands of vacuum tubes, cracked the seemingly unbreakable German Lorenz cipher, shortening the war and saving countless lives. It was the first electronic, programmable digital computer, albeit for a very specific purpose. Across the Atlantic, the ENIAC, Electronic Numerical Integrator and Computer, was unveiled in 1946. Weighing 30 tons and filling a large room, it contained 17,468 vacuum tubes. It could perform 5,000 additions per second, a speed previously unimaginable. ENIAC was a true general-purpose electronic computer, marking the dawn of the electronic computing era. Vacuum tubes were hot, fragile, and power-hungry. Then, in 1947, Bell Labs invented the transistor. This tiny semiconductor device could do the same job as a vacuum tube but was smaller, faster, more reliable, and used far less power. It was like replacing a fragile glass light bulb with an indestructible, microscopic switch. The transistor made modern electronics possible. The next leap was integrating multiple transistors onto a single silicon chip, the integrated circuit. This invention led to Moore's law, an observation that the number of transistors on a microchip doubles roughly every 2 years. This wasn't just growth, It was exponential acceleration, shrinking computers from rooms to desktops, then to pockets, at an astonishing, relentless pace. In 1971, Intel released the 4004, the world's first single-chip microprocessor. This tiny component, no bigger than a fingernail, contained all the central processing functions of a computer. It was the ultimate miniaturization, making it possible for computers to be not just smaller, but affordable enough for everyday use. The personal computer era was about to explode. Suddenly, computers weren't just for scientists and governments. Hobbyists built them in garages. Companies like Apple and IBM brought them to homes and offices. The Apple II, the Commodore 64, the IBM PC, these machines weren't just tools, they were portals to new possibilities, transforming how we worked, learned, and played, fundamentally changing our relationship with technology. Early computers were intimidating, requiring complex text commands. But in the 1970s, Xerox PARC developed the Graphical User Interface, or GUI. Apple popularized it with the Macintosh, and Microsoft with Windows. Suddenly, computers had icons, windows, and a mouse. This wasn't just a design change, it democratized computing, making it accessible to billions. While personal computers were taking off, another revolution was brewing, the Internet. Starting as ARPANET, a military research project, it evolved into a global network. Tim Berners-Lee's invention of the World Wide Web in 1989 provided a user-friendly layer, transforming a complex network into an information superhighway, connecting every corner of the globe. The Internet's commercial potential exploded in the late 90s, leading to the dot-com boom. Companies like Amazon and Google emerged, proving that digital businesses could reshape industries. Though the bubble burst, it laid the foundation for our current digital economy, where information is currency and connectivity is king. The 21st century brought the mobile revolution. Smartphones, with their touchscreens and powerful processors, put the internet, cameras, and a universe of apps into billions of pockets. These aren't just phones, they are supercomputers, more powerful than the machines that landed humans on the moon, radically changing how we communicate, navigate, and experience the world. Today, much of our computing happens not on our devices, but in the cloud. Massive data centers, spread across the globe, store and process our information, accessible from anywhere. This invisible infrastructure powers everything from streaming services to complex AI, making computing a utility, always on, always available, yet rarely seen. The latest frontier is artificial intelligence and machine learning. Computers are no longer just executing instructions, they're learning, adapting, and even creating. From predicting weather to powering self-driving cars and generating art, AI is rapidly transforming every aspect of our lives, blurring the lines between human and machine intelligence. And what's next? Quantum computing. Instead of bits representing zeros and ones, quantum computers use qubits that can be 0, 1, or both simultaneously. This allows for calculations of unimaginable complexity, potentially solving problems that would take classical computers billions of years. It's a leap into a realm where reality itself becomes the computing medium. From ancient beads to quantum entanglement, the evolution of computers isn't just a technological story, it's a story of humanity's relentless quest to understand and shape the universe. Computers are no longer just devices, they are an extension of our minds, embedded in our world, constantly evolving, pushing the boundaries of what's possible. The digital Big Bang was just the beginning. Thank you for watching. Don't forget to subscribe to Sham Discovers and turn on the notification bell for more educational videos.